Hello friends, today we are guiding you to prepare interview questions on machine learning. In comments you can share the topic of your interest. Our team will prepare the video for you. Before continue to our session, we request you to join our channel for all the latest updates. Our team of technical and subject matter experts are working hard to create valuable content just for you. So please make sure to hit the subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. How does machine learning differ from artificial intelligence? Machine learning, ML, and artificial intelligence, AI, are closely related, but they are not the same. Artificial intelligence is a broad field of computer science focused on creating systems or machines that can perform tasks that typically require human intelligence. These tasks include reasoning, problem-solving, understanding natural language, perception, and decision-making. Machine learning is a subset of AI that specifically deals with enabling machines to learn from data and improve their performance over time without being explicitly programmed. In simple terms, while AI is the broader concept of creating intelligent behavior in machines, ML is one of the ways we achieve that intelligence. For example, if AI is the goal, creating a self-driving car, then ML is the method used to train the car to recognize traffic signs, pedestrians, and road conditions through data. AI includes rule-based systems, expert systems, and planning algorithms that don't necessarily learn from data, whereas ML is all about learning patterns from data to make decisions or predictions. In summary, AI is the umbrella term for intelligent systems, and ML is a specific approach within AI that focuses on learning from data to enable that intelligence. ML powers many modern AI applications we see today. What are features and labels in machine learning? In machine learning, features and labels are fundamental concepts that play a key role in training models, especially in supervised learning. Features are the input variables or characteristics used to make predictions. They represent the data points or attributes that describe each example in the dataset. For instance, in a model predicting house prices, features could include the number of bedrooms, square footage, location, and age of the house. Features are used by the machine learning algorithm to identify patterns and relationships in the data. Labels, on the other hand, are the output or target values that the model is trying to predict. Continuing the house price example, the label would be the actual price of the house. During training, the model learns how the features relate to the label so that it can make accurate predictions on new, unseen data. In summary, features are the inputs that describe the data, and labels are the expected outputs. In supervised learning, the model is trained using both features and their corresponding labels. Understanding the correct use and selection of features and labels is crucial for building effective and accurate machine learning models. What is a feature vector? A feature vector is a key concept in machine learning. It is an array or list of numerical values that represent the features of a single data point. Each element in the vector corresponds to a specific feature or attribute that describes the data. Feature vectors are used as input to machine learning algorithms to help the model understand and process data. For example, consider a machine learning model that predicts whether an email is spam or not. The features might include the number of words in the email, the presence of certain keywords, the number of links, and so on. These features are converted into numerical values and combined into a single feature vector, such as 120, 1, 3, where each number represents a specific feature. Feature vectors make it easier for algorithms to work with complex data by converting it into a structured numerical format. In many cases, raw data such as text, images, or audio must first be pre-processed and transformed into feature vectors before it can be used for training. In summary, a feature vector is a compact numerical representation of the important characteristics of a data point, enabling machine learning models to analyze and learn from the data efficiently. What is the curse of dimensionality? The curse of dimensionality refers to the challenges and problems that arise when working with data in high-dimensional spaces. As the number of features or dimensions increases, the volume of the space grows exponentially, making the data sparse and harder to analyze effectively. In machine learning, more features can initially seem helpful, but high dimensionality often leads to overfitting, where the model learns noise rather than meaningful patterns. It also becomes difficult to visualize or interpret the data, and the model may struggle to generalize well to new, unseen data. Additionally, the distance between data points becomes less meaningful, which can degrade the performance of algorithms that rely on distance metrics, such as k-nearest neighbors or clustering. Moreover, high-dimensional datasets often require significantly more computational resources and training data to produce accurate models. Without sufficient data, the model may not capture reliable patterns, leading to poor results. To combat the curse of dimensionality, techniques like dimensionality reduction, for example, principal component analysis or feature selection, are used to reduce the number of input variables while retaining the most important information. In summary, the curse of dimensionality highlights the importance of carefully managing and selecting features to ensure effective and efficient machine learning. How do you handle missing data in a dataset? Handling missing data is a critical step in preparing a dataset for machine learning. Missing data can arise due to various reasons, such as errors during data collection or limitations in the measurement process. There are several strategies to handle missing data, and the choice depends on the type of data and the nature of the problem. One common approach is removal, where rows or columns with missing values are dropped. This is suitable when the amount of missing data is small and removing them does not lead to significant data loss. However, this method may not be ideal when missing data is widespread. Another strategy is imputation, where missing values are replaced with estimates. For numerical data, imputation can be done using the mean, median, or mode of the column. For categorical data, the missing values can be replaced with the most frequent category. More advanced techniques include using models like k-nearest neighbors, KNN, or regression to predict and fill in missing values based on other features. In cases where the missing data is not random, it might be helpful to treat it as a separate category or indicator variable, signifying the absence of data. In summary, handling missing data requires a thoughtful approach, with imputation or removal being the most common techniques, depending on the context and the nature of the dataset. Thanks for watching the video till the end. If you liked the video and haven't subscribed yet, please hit subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. In comments you can share the topic of your interest. Our team will prepare the video for you.